Hello students, this is Harish DK, HOD of Electronics, AC Independent PU College. Today, let's solve some problems on feedback in amplifiers. Before that, let us recall what we learned in the last video. See, in the last video, we derived an expression for output impedance of an amplifier with negative feedback. From that, we proved that use of negative feedback in amplifiers decreases the output impedance of an amplifier. Second, we derived an expression for the bandwidth of an amplifier, and from that we showed that use of negative feedback in amplifiers increases the bandwidth. And third, we derived an expression. From that we showed that use of negative feedback in amplifiers reduces change in the gain of an amplifier. In other words, it stabilizes the gain of an amplifier. Right? So in today's video, let us solve some problems on feedback in amplifiers. But before that, let us list out the formulas on which we can expect some problems on feedback in amplifiers. Right? Let's start. Now, children, here I want to tell you an important thing, that we derived so many equations and we extracted so many formulas. Right? So all those derivations and formulas what we extracted for an amplifier, that too an amplifier with a negative feedback, and that too an amplifier with voltage series negative feedback. So now let me consider an amplifier with negative feedback. For the last time, whenever I use a word negative feedback, it stands for voltage series negative feedback. So let me consider an amplifier with negative feedback. So you can observe this diagram. It is an amplifier with negative feedback. Here, this is a basic amplifier, or I can also call this as internal amplifier. For this amplifier, if I give the input as Vi, and what it will do is, it will amplify this input and it will give the output as Vo. Now the question is, from where we get this Vi? We are going to get this Vi from the source Vs. When no feedback is applied, okay, Vi is equal to Vs, and the gain of an amplifier is given by A is equal to Vo by Vi. But what we are doing is, I am going to apply negative feedback to this amplifier by attaching this feedback network to this amplifier. Now what this feedback network will do, it will tap this output voltage and it will extract the part of this output voltage. Here the Vf is considered to be part of Vo. Okay, now what we do is, we send this part back to the input. Now Vi is not just Vs, but it is Vs minus Vf. Now once again the question is why minus? Because it is negative feedback. Okay, then what is the gain of this feedback network? It is Vf by Vo. And we also call the gain of the feedback network as feedback factor or feedback fraction. Next, what we do is, I'm going to put this entire thing, or I'm going to place these two boxes in one more big box. Generally we call this big box as amplifier with feedback. And for this big box, the input is Vs and output is Vo. Then what will be the gain of this big box? In other words, what will be the gain of the amplifier with feedback? It is AF is equal to Vo by Vs. Makkale, one more time, whenever I write F in the subscript of any characteristic, then you should treat it as with feedback. If there is no F, then it is without feedback. Okay, here A is the gain of an amplifier without feedback or open loop gain. Here AF is the gain of an amplifier with feedback. See ನೋಡಿ, ಈ ಬಿಗ್ ಬಾಕ್ಸ್ ಒಳಗೆ ಬರೀ ಈ ಆಂಪ್ಲಿಫೈರ್ ಇದೆಯಾ ಅಥವಾ ಆಂಪ್ಲಿಫೈರ್ ವಿತ್ ಫೀಡ್ಬ್ಯಾಕ್ ಇದೆಯಾ? ಸೊ ವಿತ್ ಫೀಡ್ಬ್ಯಾಕ್ ಇದೆ. ಸೊ ಹಾಗಾಗಿ ಈ ಬಿಗ್ ಬಾಕ್ಸ್ ಗೇನನ್ನು ಆಂಪ್ಲಿಫೈರ್ ವಿತ್ ಫೀಡ್ಬ್ಯಾಕ್, ಗೇನ್ ಆಫ್ ಅನ್ ಆಂಪ್ಲಿಫೈರ್ ವಿತ್ ಫೀಡ್ಬ್ಯಾಕ್ ಅಂತ ಕರಿತೀವಿ. ಗೇನ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡೋದು ಹೆಂಗೆ? ಔಟ್ಪುಟ್ ಬೈ ಇನ್ಪುಟ್. Here the output is VO divided by input is VS, right? So we derived all the equations by considering an amplifier with voltage series negative feedback. Okay, so now let us list out the formulas on which we can expect the problems. The first one, the gain of an amplifier without feedback is given by A is equal to VO by VI. It is also called as open loop gain. Next, second one is gain of an amplifier with feedback, okay, is given by AF is equal to VO by VS, and we derived an equation to show that it decreases the gain, that is A divided by 1 plus A beta. And gain of an amplifier with feedback is also called as closed loop gain. And third one, a feedback factor, or we can call this as a feedback fraction, or we can call this as gain of the feedback network, and is given by VO by VF, where VO is the output voltage and VF is the part of the output voltage or feedback voltage. And a fourth one, input impedance of an amplifier with feedback, that is ZIF is equal to ZI into 1 plus A beta. Here ZIF is the input impedance of an amplifier with feedback, and ZI is the input impedance of an amplifier without feedback, and A is the gain of an amplifier without feedback or open loop gain, and beta is the feedback factor. Output impedance of an amplifier with negative feedback is given by ZOF is equal to ZO divided by 1 plus A beta. So here ZOF is the output impedance of an amplifier with feedback, and ZO is output impedance of an amplifier without feedback. And makle, a point to be noted here is, whenever some quantity is decreasing, then we get A 1 plus A beta in the denominator. See, we all know that use of negative feedback decreases the gain. So what happens? In that equation we are getting 1 plus A beta in the denominator, but the input impedance with negative feedback increases, so we are getting this 1 plus A beta in the numerator itself. In other words, we are writing it as a product, right? ಎಲ್ಲೆಲ್ಲಿ ಡಿವೈಡೆಡ್ ಬೈ ಅಂತ ಬರಿತೀವಿ ಅಲ್ಲೆಲ್ಲ ಆ ಕ್ವಾಂಟಿಟಿ ಡಿಕ್ರೀಸ್ ಆಗುತ್ತೆ. ಇಲ್ಲಿ ನೋಡಿ, ಔಟ್ಪುಟ್ ಇಂಪಿಡೆನ್ಸ್ ವಿತ್ ಫೀಡ್ಬ್ಯಾಕ್ is output impedance without feedback divided by 1 plus A beta ಅಂತ ಬರ್ತಿದ್ದೀವಲ್ವಾ. ಸೊ ಔಟ್ಪುಟ್ ಇಂಪಿಡೆನ್ಸ್ ವಿತ್ ಫೀಡ್ಬ್ಯಾಕ್ ಯಾವಾಗಲೂ ಔಟ್ಪುಟ್ ಇಂಪಿಡೆನ್ಸ್ ವಿತೌಟ್ ಫೀಡ್ಬ್ಯಾಕ್ಗಿಂತ ಕಮ್ಮಿ ಇರಲೇಬೇಕು, ಬಿಕಾಸ್ ಇಟ್ ಡಿಕ್ರೀಸಸ್. ಸೊ ಲೆಟ್ಸ್ ಪ್ರೊಸೀಡ್. The next one is the bandwidth of an amplifier with feedback is given by BWF is equal to BW into 1 plus A beta. Here BWF is bandwidth of an amplifier with feedback, and BW is bandwidth of an amplifier without feedback. And lower cutoff frequency of an amplifier with feedback, F1 dash is equal to F1 divided by 1 plus A beta. Okay, where F1 dash is the lower cutoff frequency of an amplifier with feedback, and F1 is lower cutoff frequency of an amplifier without feedback. And higher cutoff frequency or upper cutoff frequency of an amplifier with feedback, F2 dash is equal to F2 into 1 plus A beta, where F2 dash is upper cutoff frequency of an amplifier with feedback, and F2 is upper cutoff frequency of an amplifier without feedback, right? So by keeping all this formulae in mind, let us solve some problems. So here goes the first one. I'll just first read out the problem. An amplifier has a gain of 900, full stop. When the negative feedback is applied, the gain reduces to 250. Find the feedback factor. Before I solve this problem, I like to give you some tips. Whenever you uh, whenever you are solving a problem, you need to follow certain steps. They are: first, step number one, that is, read out the problem carefully with comma, full stop, etc. Okay. Then collect the data which is given in the problem. Step number three, use appropriate formula. Step number four, substitute the values in that formula. Step number five, get the result. And step number six, place the result with a proper unit. ಓಕೆ, ಸೊ ನೀವೆಲ್ಲರೂ ಈ ಇಷ್ಟು ಸ್ಟೆಪ್ಸ್ಗಳನ್ನು ನೀಟಾಗಿ ಫಾಲೋ ಮಾಡಬೇಕು. ಈಗ ಇಲ್ಲಿ ಕೊಟ್ಟಿರೋ ಪ್ರಾಬ್ಲಮಲ್ಲಿ ಅವ್ರೇನು ಕೊಡ್ತಾರೆ, ಆ್ಯನ್ ಆ್ಯಂಪ್ಲಿಫೈಯರ್ ಹ್ಯಾಸ್ ಎ ಗೇನ್ ಆಫ್ 900. ಸೊ ಆ್ಯನ್ ಆ್ಯಂಪ್ಲಿಫೈಯರ್ ಹ್ಯಾಸ್ ಎ ಗೇನ್ ಆಫ್ 900. ಇವಾಗ ನಿಮಗೆ ಡೌಟ್ ಬಂದುಬಿಡುತ್ತೆ, ಈಸ್ ಇಟ್ ಕ್ಲೋಸ್ ಲೂಪ್ ಗೇನ್ ಆರ್ ಎ ಓಪನ್ ಲೂಪ್ ಗೇನ್? ಸೊ ಅವಾಗ ಏನು ಮಾಡಬೇಕು, ಫರ್ದರ್ ಕಂಟಿನ್ಯೂ ಮಾಡಿ. ವೆನ್ ದ ನೆಗೆಟಿವ್ ಫೀಡ್ಬ್ಯಾಕ್ ಈಸ್ ಅಪ್ಲೈಡ್, ದೆನ್ ದ ಗೇನ್ ರೆಡ್ಯೂಸಸ್ ಟು 250. ರೈಟ್? ಯಾವಾಗಲೂ ಅಷ್ಟೇ, ನೆಗೆಟಿವ್ ಫೀಡ್ಬ್ಯಾಕ್ನಲ್ಲಿ ವಿತ್ ಫೀಡ್ಬ್ಯಾಕ್ ಗೈನ್ ಯಾವಾಗಲೂ ಕಮ್ಮಿ ಇರುತ್ತೆ, ವಿತೌಟ್ ಫೀಡ್ಬ್ಯಾಕ್ ಗೈನ್ ಯಾವಾಗಲೂ ಜಾಸ್ತಿ ಇರುತ್ತೆ. ಅಂದರೆ 900 ಬಿಕಮ್ಸ್ ಎ ಆ್ಯಂಡ್ 250 ಬಿಕಮ್ಸ್ ಎ ಎಫ್. ಫೈಂಡ್ ದ ಫೀಡ್ಬ್ಯಾಕ್ ಫ್ಯಾಕ್ಟರ್, ದಟ್ ಈಟಾ. ಸೊ what they are given A as 900, AF as 250, and beta is question mark. That is, we need to find out. But we know that AF is equal to A divided by 1 plus A beta, right? So now let us substitute for AF A in this equation. Then AF is 250 is equal to A is 900 divided by 1 plus 900 into beta. ಸೊ ಇವಾಗ ಏನು ಮಾಡೋಣ, 1 plus 900 into ಬೀಟಾನ ಕ್ರಾಸ್ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿ ಈ ಕಡೆ ಕಳಿಸೋಣ, ಈ 250ನ ಈ ಕಡೆ ಕಳಿಸೋಣ. ಸೊ then we get 1 plus 900 beta is equal to 900 by 250. So 1 plus 900 beta is equal to 900 by 250 is 3.6. So 900 beta is equal to ಈ 1ಅನ್ನು ಈ ಕಡೆ ಕಳಿಸಿದ್ರೆ ಮೈನಸ್ ಆಯಿತು, 3.6 minus 1. So that is 2.6. Then if I divide the 2.6 by 900, we get beta is equal to 0.00288, and which we can write it as beta is equal to 0.0029. ಮಕ್ಕಳ, ಈ ಒಂದು ಪ್ರಾಬ್ಲಮಲ್ಲಿ ನೀವು 3 ಪಾಯಿಂಟನ್ನು ನೋಟ್ ಮಾಡ್ಕೋಬೇಕು. ಪಾಯಿಂಟ್ ನಂಬರ್ 1, ಗೇನ್ ಆಫ್ ಆನ್ ಆ್ಯಂಪ್ಲಿಫೈಯರ್ ವಿತೌಟ್ ಫೀಡ್ಬ್ಯಾಕ್ ಯಾವಾಗಲೂ ಗೇನ್ ಆಫ್ ಆನ್ ಆ್ಯಂಪ್ಲಿಫೈಯರ್ ವಿತ್ ಫೀಡ್ಬ್ಯಾಕ್ಗಿಂತ ಜಾಸ್ತಿ ಇರುತ್ತೆ. ಆ್ಯಂಡ್ ಸೆಕೆಂಡ್ ಪಾಯಿಂಟ್ ಏನಪ್ಪ ಅಂದರೆ, ಬೀಟಾ ವ್ಯಾಲ್ಯೂ ಯಾವಾಗಲೂ ನಿಮಗೆ ಲೆಸ್ ದ್ಯಾನ್ 1 ಇರಬೇಕು. ಇಟ್ ಕೆನಾಟ್ ಬಿ ಗ್ರೇಟರ್ ದ್ಯಾನ್ 1. ಓಕೆ, ಇಸ್ ಅ ಕ್ಲಿಯರ್? ಸೊ ನೌ ಲೆಟ್ ಅಸ್ ಪ್ರೊಸೀಡ್ ವಿತ್ ದ ಸೆಕೆಂಡ್ ಪ್ರಾಬ್ಲಮ್. Here goes the second one. An amplifier has an open loop gain of 7500. Full stop. Determine the gain when 0.5% negative feedback is introduced. So here they clearly mentioned the gain, open loop gain, that is gain of an amplifier without feedback, as 7500. Determine the gain when 0.5% negative feedback is applied. So here what they are mentioning is they are providing us the value of beta as a percentage. So ಇದನ್ನು ನಾವು ಒಂದು ಫ್ರ್ಯಾಕ್ಷನ್ ಆಗಿ ಕನ್ವರ್ಟ್ ಮಾಡ್ಕೋಬೇಕು. ಸೊ ಇಲ್ಲಿ ಏನಂತ ಕೊಟ್ಟಿದ್ದಾರೆ, ಗಿವನ್ ಎ is equal to 7500, but beta is 0.5%, which is nothing but 0.5 divided by 100, which is given by 0.005. Then what we need to find out, determine the gain with negative feedback. Okay, that is, we need to find out EAF, and we know that EAF is equal to A divided by 1 plus A beta. So EAF is equal to A is 7500 divided by 1 plus 7500 into beta. Beta is 0.005. Then it comes to, when I simplify this, it comes to AF is equal to 194.8. Okay, 194.8. So hope you understood the two problems. Now let us proceed with the third one. So here comes the third one. Let us read out the problem first. An amplifier has a bandwidth of 220 kilohertz and voltage gain of 100. Calculate the gain and bandwidth if 10% negative feedback is incorporated. So this is the given problem. So in this problem what they are saying, they have an amplifier with a bandwidth 220 kilohertz, and point to be noted here, they are not mentioned it as it is a bandwidth with feedback, so it will be BW, and voltage gain of 100, and here also they are not mentioning it as with a negative feedback, so it is just A. And what they are saying, calculate the gain and bandwidth. We need to calculate the gain and bandwidth after negative feedback is incorporated. Then we should calculate the gain with feedback and bandwidth with feedback. Okay, so now let's start with the solution. We need to write down the given data. So they are given bandwidth 220 kilohertz. The second one, they are given gain without feedback, that is 100, and they are given beta when 10% of negative feedback is incorporated. So beta is 10%. So 10% in the sense it is 10 by 100, which comes to 0.1. So now we need to find out BWF and AF. So it is a very easy problem and a straight problem. So let's solve this. Now we know that BWF is equal to BW into 1 plus A beta. So let us substitute for BW, A and beta. So here BW is 220 kilohertz, that is 220 into 10 power 3 into 1 plus A. A is 100 and beta is 0.1. Beta is 0.1. So we substituted that. 100 into 0.1 is 10. 10 plus 1 is 11. So this becomes 11 into 220. That is 2420 kilohertz, or we can write this as 2.42 megahertz. Okay, but ishtike barad nilsudru saku. It is a very simple problem. The next part, we know that AF is equal to A divided by 1 plus A beta. So that is AF is gain with feedback. So which is equal to A is 100 divided by 1 plus 100 into 0.1. Beta is 0.1. 100 into 0.1 is 10. 10 plus 1 is 11. 100 by 11 is just upon 9.09. Right? So now it is a very easy problem, and in this chapter or on this chapter you can expect only simple problems. Okay, now let us proceed with the fourth one. The fourth problem is somewhat like this. The input and output voltages of an amplifier are 10 millivolt and 4 volt respectively. If the gain with negative feedback is 200 and input impedance without feedback is 5 kilo ohm, find the feedback fraction and input impedance with feedback. So it is a very clear-cut problem. They're given the data very it is a straight problem. So here let us note down what they are given. The input and output voltages of an amplifier. See here they just mentioned it as an amplifier, it is not with feedback. So it is the input, and this will be VI and this will be VO. So that is input to the basic amplifier. Okay, and they are mentioning here if the gain with negative feedback is 200, that is AF, they are given AF, and input impedance also they are given. Input impedance, that is ZI without feedback, that is input impedance without feedback, ZI is 5 kilo ohm. Find the feedback fraction, that we need to find out beta, and input impedance with feedback, that is ZIF. Okay, so now let us write down the data what they are given. They are given VI is equal to 10 millivolt, VO is equal to 4 volt, and AF is 200, ZI is 5 kilo ohm. we need to find out beta and ZIF. So we know that A is equal to VO by VI. So VO is 4 volt and VI is, that is 10 millivolt, 10 into 10 power 3. Oh sorry, it should be minus 3. So 10 into 10 power minus 3. So which comes around 400. So now let us straight away calculate the gain of an amplifier. That is AF is equal to A divided by 1 plus A beta. They are given AF, we calculated A and we need to find out beta. So that is 200, AF is 200 and A is 400 divided by 1 plus 400 into beta. ಈಗ next ನಾವೇನು ಮಾಡ್ತೀವಿ 1 plus 400 into beta is cross multiplied and send it this side, and this 200 is brought down in the denominator. Okay, so next ಏನಾಗುತ್ತೆ 1 plus 400 beta is equal to 400 by 200, that is 2. Okay, so then 400 beta is equal to 2 minus 1. So even ಈ ಕಡೆ ಬಂದರೆ minus ಆಗುತ್ತೆ, so 2 minus 1. So 400 beta is equal to 1 and beta is equal to 1 by 400 and it is found to be 0.0025. Beta is 0.0025. So now by using this beta A, let us calculate ZIF, and we know that ZIF is equal to ZI into 1 plus A beta. Here they are given ZI as 5 kilo ohms, that is 5 into 10 power 3 into 1 plus A is 400 and beta just now we calculated, that is into 0.0025, and it comes around 10 kilo ohms. So it is 400 into 0.0025 is 1. So 1 plus 1 is 2. 2 into 5 is 10 kilo ohms. 2 into 5 is 10 kilo ohms. So now we calculated ZIF as 10 kilo ohms. Okay students, and it is a very simple problem. You can expect this problem for 3 marks. Next, let us proceed with the one more problem. An RC coupled amplifier has a voltage gain of 2000 and lower and upper 3 dB frequencies are 100 Hz and 100 kHz. Find the gain upper 3 dB frequency and bandwidth if 15% negative feedback is introduced. So this is the given problem. So in this problem, see, ಇಲ್ಲಿ ಕಟ್ ಆಫ್ ಅಂತ ಬ್ರಾಕೆಟಲ್ಲಿ ನಾನು ಬರೆದಿದ್ದೀನಿ ಬಿಕಾಸ್ 3 dB frequencies are nothing but cut off frequencies. Okay, and about this you are going to learn in detail in your amplifier chapter. Okay, so now let us collect the data what they are given in this problem. So first what they are given is, they are given the voltage gain of amplifier as 2000, that is they are given A is equal to 2000. Lower and upper cutoff frequencies are, that is F1 and F2. F1 is 100 Hz and F2 is 100 kHz. 100 kHz can be written as 100 into 10 power 3 Hz. So find the gain, that is gain AA, and upper 3 dB frequency, that is F2, and bandwidth if 15% negative feedback is introduced. So 15% ಏನಪ್ಪಾ ಅಂದ್ರೆ it is nothing but beta. 15% can be converted as 0.15 because 15 divided by 100 is 0.15. So what we need to find out, gain, upper 3 dB frequency and bandwidth with feedback. So we need to find out AF, BWF and F2 dash. So let us start. We know that AF is equal to A divided by 1 plus A beta. So what they are given? They are given A, that is 2000 divided by 1 plus 2000 into beta, that is 0.15. So here 2000 into 0.15 is 300. So 300 plus 1 is 301. So 2000 divided by 301 is 6.644. 6.644. So the gain with feedback is 6.644. Next, let us calculate F2 dash. So we know that F2 dash is equal to F2 into 1 plus A beta. So F2, they are given upper cutoff frequency of an amplifier without feedback as 100 kilohertz. So it is F2 is 100 kilo into 1 plus A is 2000 into 0.15. So 2000 into 0.15 is 300. 300 plus 1 is 301. 301 into 100 is 30,100 kilohertz, can be written as 30.1 megahertz. ಸೊ ಈ ಥರ ಕನ್ವರ್ಷನ್ಸ್ ನಿಮಗೆ ಮಾಡೋದು ಗೊತ್ತಾಗಲಿಲ್ಲ ಅಂದರೆ ಆನ್ಸರ್ನ ಇಷ್ಟೇ ಬರೆದುಬಿಟ್ಟು ಹರ್ಟ್ಸ್ ಅಂತ ಇಟ್ಬಿಡಿ. ಓಕೆ, ಸೊ ನೆಕ್ಸ್ಟ್ is, but what is bandwidth of any amplifier? Bandwidth is nothing but upper cutoff frequency minus lower cutoff frequency. So here they are given upper cutoff frequency as 100 kilohertz and lower cutoff frequency as 100 hertz. So 100 into 10 power 3 minus 100, it comes around 1 lakh minus 100, or 99.9 kilohertz. So, and we know that bandwidth with feedback is equal to BW into 1 plus A beta. So we know the BW, just now we calculated, we know A and we know beta, and let us calculate BWF. So BWF is equal to 99.9 into 10 power 3 because it is kilohertz into 1 plus A is 2000 into 0.15. 2000 into 0.15 is 300. 300 plus 1 is 301. So it is 99.9 into 10 power 3 into into 301. It comes around this much, and it can be written as 30.069 megahertz. 30.069 megahertz. Okay children, hope you understood the sample problems. Okay, remaining problems will be posted in your website. Okay, until then, go through the problem, practice it, and go through the textbook problems and try to solve by yourself. Okay, all the best. Thank you.